guys.
All right, so there are 3 sessions to go still. The first session now is the panel for overcoming industry challenges in at-scale system firmware lifecycle. So first of all, let us do a round of introduction on the people on the panel. I'm Dongwei from ARM, steering committee member representing OPF, right? Open Platform Firmware. And I'm the moderator for this panel session. So I think I asked the panelists to sit according to the chart you see on the screen. So let's start from Raj to introduce yourself.
Hi, I'm Raj, AMD Chief Firmware Architect, responsible for all things strategic initiatives related to firmware and the hardware side of things at AMD.
Hey, this is Srini from AMI. I'm VP at Boot Firmware Technology Group.
Yeah, I'm Chris. I'm from 9 Elements, and I'm managing the firmware team there and doing a lot of open source firmware work.
Hi everyone, I'm Bertrand from Google. I lead a team called Boot Services, and we are responsible for the BIOS and the boot flow of Google servers and some appliances.
And I'm Allison Goodman, and I lead platform firmware strategies for Intel for our customers and ecosystem partners.
Thank you all, panelists. I'm kind of in the way because we don't have a remote mouse to click through. So for open firmware, open platform firmware lifecycle, the topics that we are interested in and we are going to be talking about are on the list here. You know, the platform designs, platform firmware deployment, platform integration, validation of the system, deployment, security. You know, we mentioned that earlier, right? Telemetry, you know, the BMCs and remote management, remote root cause and firmware updates. We mentioned that many times. Sustainability, source code management, software practices, collaboration models. We're going to be going through these topics in this panel discussions. So from your perspective, I mean, you guys, from your perspective, what are the top 2 or 3 challenges in this firmware lifecycle topic? Let's go from Allison first to this time.
Yeah, I can do a quick review of the slide. At least from the perspective of a consumer, a hyperscaler, namely Google in this case, of the current model, we see that closed source proprietary firmware creates extra challenges. It's hard to audit from a security perspective. We don't know what's in there. It creates the opportunity for some supply chain attacks also. It creates also a reliance on the vendor's willingness to support, and it's not that nobody's willing to not support, it's more about alignment of incentives and whether those incentives are going to stay aligned for the long time. Additionally, closed source firmware creates compliance challenges, sometimes in terms of licensing, sometimes in terms of the inability to create a software bill of materials, which is now a regulatory requirement in some markets. And also we need around 10 years of support, which we don't always get solely from the support of specific vendors. So open source helps extend that support. The lack of firmware standardization creates high coupling between components. When we get code drops that contain different software that are patched together, we don't really know what has been patched, we don't really know where it comes from, so it's more difficult. And it's also very hard to rebase and upstream those versions. And speaking of lack of upstream support, not having upstream support creates duplication of work, duplication of code. It's very difficult to maintain that in the long term because when there is an update upstream, it's very hard to port it back to those firmware packages that are all cobbled together. So in practice, the challenges in terms of how we can solve this, in terms of intellectual property, not everything has to be open source, but we need to make sure that we have proper isolation between the components, and that will allow to make sure that what is not open source can live its own life, and we can have the full benefit of open source elsewhere. Some examples in terms of what has been open sourced by some actors would be OpenSeal from AMD, the Trusted Firmware from ARM, the FSP from Intel. Some very good initiatives that we can follow. Speaking of open sourcing, it's not free. It takes effort to work with the maintainers to make sure that the quality standards are met and to make sure that the code is upstreamed. But it's not free. It's an investment. We are at OCP. I think we all know the value it brings, but yeah, needs to have an alignment to do that. Firmware is growing in size of complexity. That's mainly due to the growth of silicon complexity. We need to approach it more and more like, for instance, something like the Linux kernel, where there are maintainers, groups of people working together from different entities. It's no longer something that we can do once at the beginning of a project in a small team and then move on. And finally, in the firmware space, just like we need to ramp up in how we collaborate together, we need to ramp up also in terms of the availability of CI/CD pipelines, testing, make sure that all the actors have the same testing code base, make sure that we can all test the same code, etc. So this was kind of an intro we had for the panel, and I'm curious to see what the others are thinking about that.
You can start with Allison.
Yeah, let's start from Allison's side, coming around to address this question that that was illustrated here, right? About the challenges that we might be facing.
I think there are plenty of challenges, so I'll just list off two from my perspective right now. The first is really around just change management and change control. I think, you know, it's such a critical, firmware is such a critical aspect of deployment. And when you look at all that we have to do in terms of the growing silicon complexity that was called out, our desire to have a lot of control and configurability and all these new features, and then also that we have to just refactor and maintain it on a constant basis. So you have all these different things trying to invoke change into that base, and we're trying to then have a great amount of control over that change. And so it's definitely a difficulty for all of us. And then the second one I just want to point out is just that open source investment. I agree, Intel's been a huge contributor to open source for many, many years. And we've done so with a lot of resourcing. We put a lot of money and people and time into it. And that's going to have to continue. And it's going to take all of us also putting in that money and time to keep it relevant. So it's not just the new features, it's the security fixes and other things that really have to be timely in the check-ins to open source.
Should I go on? Yeah. So yeah, totally resonate on the open source part, right? I think part of the complexity in firmware is, of course, due to the silicon, to the complexity in silicon, but not only or solely, right? So, and that's also, I think, one thing that we have to work on what is like the core of features and how can we simplify that, right? And of course, there's room for value add then in firmware, but I think that's like one of the things that we work on. Standardization is for sure one of the big problems on open platform firmware. There are some standards out there like UFI, for example, that is there and existent, but from a history perspective, it doesn't fit all use cases. So. And having more standardization there, into the silicon, and also into the operating system, and all these kind of things is something that we really work on. And talking about open source, I think we have to understand what open source really means, right? And what does open source development means? What does open source code means? And open source is not. There's a difference between open source and publicly available code, and that's I think I need. You talked about cultural change or management change, and I think that's really something that has to happen. That where we have to educate people and show them the way on. This is how things need to be done, and this is how we can move forward.
So I think there are a couple of areas where we can standardize. One is the complexity, the way firmware is today very complex. Look at it, we have x86, which is a dominant architecture, and then we got ARM right now, and then the distant future we will see RISC-V. So as far as CPU architecture is concerned, there are multiple architectures, and then The next one is we have different firmwares. One is UFI, core boot, slim boot, U-boot. There are multiple architectures. And then we talked about silicon reference code implementation, OpenCell, AMD OpenCell, Intel FSP, TFA. So all these combinations and permutations in a data center, we have multiple variations. How do we maintain it? So there, I think, as part of a reference code, silicon code, that could be some standardization which will minimize this complexity. And the next one will be to feed what is the input to this silicon reference code. This is the platform configuration knobs. The thousands of platform configuration knobs are present, and how do we, there are two types. When you're building the firmware, hey, what is the standardization we can do so that it is easier to create the BIOS using these configuration knobs. And then the second one will be once it is deployed, hey, how do we change particular configurations alone without updating the BIOS? So there is no standardization in those. There are multiple variations of implementation available, but there is no standard available, which can be securely, we can go and update these configuration knobs on a deployed platform. So there are a couple of areas we can look at it.
Yep. Yeah, I think we talked about a barrage of issues that we as silicon vendors, we as platform integrators, firmware vendors, we face through in support of firmware for the platforms that go into these mega data centers and cloud service providers and whatnot. We did talk about in somewhat detail on the open sourcing aspect of it. Totally agree. Open sourcing is not free. It does take a lot of commitment through the organizational chain. And it takes a lot of resources and whatnot, a lot of planning to get a certain firmware or software open sourced. And oftentimes the dynamic nature of businesses dictate, where you want to prioritize your resources. And unfortunately, open source does take a hit during tough times. But as soon as the business picks up, the priority gets put back on, and so there's always waxing and waning of open sourcing and whatnot. But I'm hoping that in the future that there would be some independence from the business dynamics. And we'd be able to solve that in the future. But one of the things that I think I'll bring the topic in, the one that is that we want to do a deep dive on, that you have some questions on. It has to do with silicon initialization itself. And so I think the main idea, or the main problem statement is that of a platform integrator or a platform designer, right? That have to deal with multiple silicon vendors and how it impacts the entire software firmware stack, the development of it, the maintainability of it, the validation of it, and how that spirals into the cost of the development of the SoC itself and the platform as well. So. Yeah, it's an interesting topic for the panel today.
Yeah, let's come back to that a little bit. So I want to echo what the panelists have been saying, right? I think the standard development and the open source investment are very critical in facing these challenges. And I think we have relatively been good at developing the standards. The open source side, I think, definitely is a challenge, especially like Raj said, in a difficult time when the investment may not be there, right? So I have been seeing spec have been developed and it's going on as is and very smoothly, but the open source implementation, trying to keep track of the standards, are lagging behind, right? And the other challenge related to this is that the firmware development, even though it is software, but it's a smaller community, not like the applications or the operating system kernels where you have a much larger community. So when some maintainers leave the scene, it is a challenge to find the other volunteers to keep up. So I think I've seen some of these challenges.
Yeah. I'd also like to digress a little bit into what you mentioned, Chris, about what truly open sourcing is. It's not something that you take piece of firmware or software, just put it out there, right? There's a whole responsibility around it as well, the governance model and how you want to nurture the open source aspect of it, how you want to get the open source partners to partner with you, feel the sense of belonging to the development of that and nurturing of that software. So maybe you can expand a little bit on that.
Yeah. So I think what has been happening in the past was for sure that, as I mentioned before, like the open source part and public available part got confused, right? And the thing is, when you start developing something closed, and at some point in time, you jump out of the door and say, here it is, consume it now, and work with it. That normally just doesn't work, right? So you have to, when we're thinking about open platform firmware and about a open source development model, we have to think about how can we make the whole development flow as open source as possible, really from the start. And into the communities, right? How do we engage the communities that are there? And you mentioned correctly that there are a couple of different projects out there, right? That consume probably something like OpenSIL or FSPs, and we have to kind of get them all on board on that process. And that only works with like very early engagement on. And I think that dream of we wrote that perfect thing, and now all come and eat from my table here, right, and go with it. I think that just doesn't exist, right? That just doesn't work. And I think that we noticed that this doesn't work, and I think that's like the cultural change really that needs to happen there, and the change of mind on how we approach that and how we do open source development.
The mindset. It's having the right mindset for open sourcing.
Yeah, exactly.
Yeah, that's right. So I think, Raj, you brought up this topic of silicon initialization challenge, right? So I'd like to hear from, the different perspective from the silicon vendors, from the, the IBV, from the integrators, either on the cloud side or the OEM, ODM side. Right, so maybe you can start helping us to formulate that.
Absolutely, and then I can hand it over to Allison there, since she's my partner in crime. So the problem statement around platform integration is that you consider a platform manufacturer such as Google, Meta, or whoever have you. They design a platform around a barrage of different silicon vendors. Intel, ARM, AMD, and so on and so forth. And so every silicon vendor has their own requirements of initializing their silicon. So they have their own sequences, own requirements, and so there is a layer above the silicon initialization that calls into these APIs, if you will, and performs the necessary sequence of initialization. Although the silicon initialization itself is developed by the ISVs, but it's the upper layers, such as UEFI-based EDK2 or Coreboot or whatever the host firmware is. They have to call it into a certain sequence, and the API themselves are different from vendor to silicon vendor to silicon vendor. So that's what the challenge is. Now, as a result of all of this, what happens, you have to have a team that supports a silicon vendor within the platform organization, right? So you have to have a team that supports Intel silicon, a team that supports ARM silicon, a team that supports AMD silicon. So so you have this vertical set of organization, three set of resources. And that increases your resource profile. Now you have to maintain that code as well, the upper layers, for the three different silicon vendors. And that also is an addition to the cost of the platform. that you are developing, and then you have to maintain the code in source code management system. There's complexity there, and then having to validate all these 3 different layers separately. So all of this add and feed into the carbon emission footprint, right? Which is one of the things that we talk about here at OCP quite often. And so so it's not very efficient. It generates a large carbon footprint during a development at the platform integrator. So we have to come up with a solution to resolve that. We need to come up with a thinner profile that allows you to scale in a way that it lowers the carbon emission. And so on and so forth. So that is the problem statement. I'm not going to be talking about the solution or anything of that kind, at least.
Yeah.
But yeah, Allison.
Thanks, Raj. And I think I'll add on that, yes, the problem in front of us is really to look at the abstraction layers and modularity that we need to get into the firmware that we have today so that we can get that level of commonness. So it's, the things that are very specific to the silicon, we push down and we hold low next to the silicon, and those things that can be common and shared and make it easier for that integration across to get those in the right spot. And so I think earlier today, one of the speakers was saying that firmware is software, which is true. We have to embrace the software aspects and the capabilities that we have in a software to do the type of modularity and the abstractions that we need. And at the same time, we have to acknowledge that firmware is also not software because it's intrinsically tied to the hardware. And there's going to be aspects of it that are always super tied to the hardware and are part of the control and the configurability that we want into that hardware. And so our challenge is really to how do we narrow down, specifically what really is hooked to the silicon, and then where can we abstract so that you can have different silicon implementations, because we will. And silicon doesn't show up on a regular cadence. It has big, wide steps in between. So that's the piece that we'll solve together.
Yeah, I'd like to just kind of adjust Raj's statement a little bit, because in the ARM ecosystem, the picture is a little bit different, because so far today, ARM has not produced a silicon yet, right? It is our ecosystem silicon providers working with us to produce the silicon. So in a sense that we have seen this problem a lot earlier, and that's why the ARM trusted firmware was created, because if each of our silicon vendors, Qualcomm, Ampere, NVIDIA, and all these hyperscalers, if they all create their own silicon initialization, this is not ×2, it is ×n, right?
That is correct.
Yeah, so that's why we created the ARM trusted firmware to encourage people to adopt that framework, which is open source, and also we have standard interfaces defined for these open source framework as well. So, but of course, in this discussion, as you can see, that trusted firmware doesn't span across architecture. So when you're talking about x86 or any other architecture, that's a different issue that we might have to address, right?
Right.
Just as an IFE, I just want to add a couple of points, right? It's just not Intel FSP, AMD OpenCell, and ATF within a single provider at silicon vendor itself. Based on the vertical segment, there are some it doesn't align. So it is a very complex firmware gets generated and needs to be updated on the field, and then it has to be maintained for such a long time. It's a very cumbersome process. So
that doesn't happen with AMD, does it?
Sure. Yeah. So these things are, for sure. If we standardize it, yes, that's going to compress the timeline. The whole development timeline can be compressed, and also we can update it in the field. It will be a lot easier. Yeah. Other couple of things is, for sure, all the reference code should come with an SBOM. And also we should look for another framework where we can validate the security vulnerabilities that are being coming up. We should be able to say, hey, yes, this particular vulnerability has been detected and been fixed. So it's something we should all come up with a joint framework which can run on any SoC. It need not be specific to a particular vendor.
Yeah, Bertrand, do you want to share a little bit on this topic? Because you come looking at this problem from the consumer side of the equation, right?
Yeah.
You'll be representing the world.
I don't know if I
Let's
can
solve the
pretend
world hunger today.
to do that, but for sure we have faced this challenge. And I would say even in the case of ARM TFA, it's true that it's a very good example of what can be done to simplify and standardize. But even then, open source is not just, I think, Chris, you touched on that, it's not just something being available or something being shared, it's also how you work with it. Because someone could take TFA, do some tweaks in it, and then never touch it again, and then at some point you end up with a fork of TFA that is not updated, and it becomes, if you wait and if you don't take action immediately to make sure it lives at the same plane than whatever is upstream, then you end up with a very old TFA, and then one day you get an update in the upstream TFA that you want to ingest, and it's very difficult because you have a fork that is maybe 18 months old with a bunch of patches, and it's very difficult to ingest those changes. So I would say even open sourcing by itself is not a solution. The solution is the full ecosystem to completely embrace the collaboration model and make sure that there is a certain level of hygiene that is being put by everyone involved, that people making modifications, they upstream them, that the maintainers are actually making an effort to work with the people that want to do pull requests and that they can also accept these. So it's a full ecosystem that needs to work together, and I hope that this panel and your contribution and your presence will help drive that across the community.
Yeah, I think the step one has been taken. In the keynote, if everybody remembers the first day where Intel and AMD announced a partnership between the two, and to solve some of the world's toughest problems. And so this is a pretty big problem statement as well. And I think to begin with, at least from an x86 perspective, both Intel and AMD can come together and solve that problem. We don't want to talk about the solution. We do know what the objectives are, but we should be talking about this problem statement and come up with an aligned solution together under the OPF project.
Yeah. So, I mean, Raj, you said, the challenge will really be, coming up with a solution that we can find a common, silicon interface, right, on how we initialize firmware. And I think that's like really will be one of the toughest challenge, right? So, only in the x86 world, right, like AMD and Intel, the SOCs are booting in a completely different way, right? So even there, it's like utterly hard to come up with an interface that kind of fits both use cases, right? And if we extend that to ARM as well, right, and thinking about RISC-V as well, right? So there's like a huge amount of configuration options, right? Things that we have to plug in here and there, right? Different ways on how we initialize that silicon in the end. And all that needs to, come down to one common interface that we talk to, right? That will be like a huge task.
Right.
However, I think if we can pull that off, that will make all of our lives very, very easy or much easier, right? So from an IBV perspective, right, if I only have, I mean, you can probably resonate on that, right? If we only have one interface that we talk to, right?
Yeah.
That's like easy. And if from an open source firmware perspective, it's quite a challenge to maintain all the different SOCs, all the different architectures, all the different ways on how these SOCs and architectures get initialized. And simplifying that, I think, would help the whole health of the code base, right? Make it much more healthier, much more cleaner, and much more maintainable, right? Easier maintainable. And of course, on the other hand, we have to take care of that. In the end, we don't hide everything just behind that interface, right? And that open source firmware is a lie in the end, right? So I think that, and that's kind of doing that challenge, right, and doing that way there and finding the right middle ground, I think it's that will be very challenging, but I think that's solvable.
Yep.
Okay, so switching the topic a little bit, so I think security is also another challenge that people often mention, right? So I'd like to hear, what would you recommend to overcome some of these challenges in firmware security part? Any volunteers?
Yeah, just a couple of points I did mention before. SBOM, releasing SBOM along with the silicon reference code is a must. I think people are moving towards that, but we are not there. I think maybe near future will be there. And also some kind of a framework we need to have to validate the security vulnerabilities in the silicon reference code. So I think that will help to make sure that all the vulnerabilities are fixed and being pushed to the ecosystem.
Maybe one aspect that will help security is also an intentional effort in terms of code quality, testing, etc. A lot of vulnerabilities are coming from, I would say, inadequate code or simply time to market constraints that force engineers to go fast. And sometimes if we go too fast, we introduce vulnerabilities. Another important aspect that can be addressed in terms of specification would be to make sure that the code bases can be compiled with the latest version of the compilers, that we don't require exotic tool chains, that the tool chains are made following a certain quality standard, not the tool chain, sorry, but the build environment is made following certain quality standards. All of this is going to help in terms of security, even though the purpose is not necessarily to directly address a precise security vulnerability. It's just setting up the frame so that we're not going to inadvertently reduce the security posture of the firmware by trying to take shortcuts elsewhere.
Yeah, that totally resonate with that. So I think open source is like one of the biggest solutions of that, right? So I think we all know, and I know you probably get tired of me saying open source, but every cryptographic algorithm out there, like every crypto that you do in the world, like every security, that's developed in the public, right? Publicly available, right? So we know that this stuff breaks. And a lot of points that you brought up, right, is really about transparency, right? Having a way to look into what is happening, what is shipping, right? And SBOM is like one part of the equation, really. And I think like open sourcing is the other part of that.
I agree with the open source comment, and also remind everybody to make sure that they push their security fixes into open source in a timely manner.
Yes, Intel agrees with
very
open
important.
sourcing.
Yeah. And then also, yes, that like the more that we can create clear contracts and for that modularity, it makes it easier to run a lot of those quality tests and make sure that we're like enforcing and understanding exactly what those handshakes are and where we could introduce a new handshake that would be a security boundary and pull it out quickly.
Right. Yeah, I'd like to bound the problem statement or bind it to a smaller area. Today, our hardware is fairly complex. It's got like thousands of microcontrollers, and that are required during the boot up process, right? So I'll bind it into a smaller area of the host processor, the firmware running in the host processor. So let's bind it there. Now, from AMD perspective, there are these our security kahunas sitting back there. I won't be speaking for them, but I know for sure that the wider the surface area is, the more prone it is to being attacked by a malware, right? And one of the things that we need to do is to reduce the surface area of attack by simpler firmware initialization sequences and making that entire stack simpler and thinner. So thereby lowering the surface of attack and making it much more secure. And you've heard this response all over on the internet that move the non-essential drivers away from the firmware into the OS drivers area, right? It's much more easier to be maintained there. It is much more challenging to maintain a firmware that is rich with all sorts of features and whatnot. So that is another area that we can look at. We probably cannot solve the entire we cannot probably solve the world hunger here, so to speak, but we can do our part from a firmware perspective for sure.
Yeah, but just one point, Raj. Yeah, what you said is correct, and Christian was saying right. Hey, it is a very big task to take ARM, Exit, Intel, ARM, AMD, everybody's risk maybe to come up with a single interface. But a low-hanging fruit, I think it is to do for x86, since that may be because there's a common architecture. It could be easier to come up with a API which will work for both.
Right, and also things like, we get sucked into the backward compatibility. Like for example, Sarthi, where are you? Yeah. So you've been working on 64-bit architecture for UEFI, right? So that is one of the areas where you don't have to solve, you don't have to have support for 32-bit or the previous generations. You got to move forward with it. There are now platforms that support 64-bit only. You don't need to go into 32-bit, things of that nature. These are low-hanging fruits that you can solve and make your firmware much secure. That way.
Have we removed the DOS support yet?
That's a good one.
I think one aspect that will help both time to market and security, as Chris mentioned, it's actually very hard to do security when you do cryptography, to implement all of this properly. So the first point is also to try to not reinvent the wheel. Like there are things that exist that are out there, like Calyptra, for instance, use them because they work, they are secure, and it's much better than trying to redo something in an obscure fork somewhere, or custom implementation that we are then going to have to spend time to integrate. It's much better to use something standardized.
Okay, I think we're kind of running out of time. Any questions for the panelists? Yes, could you get to the mic?
Please stick to the scripts, okay?
Thanks for the excellent discussion here. One thing that we probably didn't have time to touch upon is root cause, right? When we have different layers of the firmware stack owned by different entities, let's say a misconfiguration of a feature in the silicon code won't manifest as silicon code bug. It will manifest as some platform code or OS bug, right? So when we're going to have a root cause of that, when we have different layers owned by different entities, that's a challenge in itself to go and figure out, who needs to own that debug and root cause, right? Any thoughts on that?
Maybe I think something that would help from experience is proper testing at each layer. Because if you can isolate a bug using test sets that are shared between the different entities, like the different entities that write the firmware together, it should help because you're able to say, okay, this module is working properly. We have those tests that proves it. This one, however, this test is failing. And very often bugs are found simply because there are test escape. So if we all collectively make an effort to do more testing and implement more tests, we are not even going to have bugs because we'll find those bugs during development and not during the release. So I think what you're describing is more of a symptom of a lack of testing, which is a bit prevalent right now in the firmware space, and is something that we can address proactively, I think.
We can take it offline, but I have more follow-up on that. Right? Interface definition, we can always fuzz the interface definitions and make sure that they are solid. But hardware behaves differently, right? So if I misconfigure a hardware, the interface is fine. We validate the interface. But if I misconfigure the hardware, it won't manifest as a bug in the silicon code. It'll manifest as some OS or a RAS event, whatever. So that's a very hard one to debug. But we can talk about it later.
Yeah, good one.
Yeah, okay. So give a round of applause to the panelists. Thank you.